and good afternoon. Um, Welcome to this call. Um, we are happy to have all of you here with the Software Cross People India community. A little bit about SCI. SCI is a not-for-profit organization dedicated to connecting individuals with the software craftsmanship mindset, and our mission is to foster a community where members can improve their skills and get better at software craft. We organize talks, roundtables, workshops aimed at enhancing the craft in software development throughout the year. We invite several industry experts to share their insights and expertise with our community. Incubite is the founder and sponsor of this community. We are a company focused on delivering well-crafted software solutions. This talk will be going on various platforms that you see on your screen right now. So we'll be sharing a link to these after the talk so that you can, if you miss some bit of it, you can go there and check it out. That's about SEI. And coming to today's session, we are joined by Paul Hammond. Um, hey, Paul. Um, just a little bit of intro for Paul. Um, I mean, to start with, I've personally been following Paul's work for several years, his LinkedIn posts, podcasts, talks. So I couldn't be more excited that he agreed to come on. Um, so Paul is a contract product engineer based in Manchester, UK. Um, Paul comes with over 2 decades of experience building software at organizations including the BBC, Sky, Electronic Arts, and Equal Experts. He's been a long time advocate for extreme programming practices, and he regularly delivers 3D workshops to development teams. He's currently experimenting with combining XP techniques and AI agents and maintains an open source Cloud Code framework that encodes these practices into agent workflows. I'll be dropping a link for that in the chat real shortly. And as I said, I've been quite honored and quite excited about this talk. So welcome, Paul, to the SCI community. And
Thank you.
with respect to questions, feel free to send your questions in the chat. Um, Paul, feel free to respond at your own rhythm if we get a little break in the middle, or we could simply take them in the end. With that, Paul, the stage is yours.
Thank you very much. Yeah, thank you. I'll just share my screen. Cool. Can you all see that? All good?
Yep.
Yep. Yep. Cool. Thank you. Yeah, and yeah, thank you, Siddharth, for inviting me here as well. It's quite excited to give the talk as well. So as you say, I'm a contract products engineer from the UK, and for about the last year or so, I've been trying to answer a question that I think a lot of you are probably dealing with right now, and that's how do you make AI assisted development sustainable? So it's not just fast, but actually sustainable in the long term. And the answer that I seem to be kind of heading towards at the moment is that, for me at least, it seems to be a combination of XP practices that I've been kind of doing for about the last 20 years, some architectural patterns that I've been invested in learning specifically because I believe that they would help. And yeah, but basically, I just want to kind of present some of that to you all on this call. So what I'm going to do on this call is after going through some of the theory and showing you some of the kind of rules that I've added, we'll do a bit of a live kind of AI coded session. And I'm going to build a new adapter for a system that I've got, and we should see that hopefully working end to end. So again, a little bit of background about myself. You've obviously mentioned already some of this, but yes, I've been doing this for about 20 years. Worked for various companies like the BBC and Sky and so on. And throughout pretty much all of that, or for the vast majority of that time, I've been a pretty consistent practitioner of extreme programming techniques. So by that, I mean things like test-driven development, pair programming, the continuous integration side of things. And while I have spent a fair amount of time on the front end over the last, 7 or 8 years or so, I used to actually be primarily a back-end developer. And so I know that these same techniques work across the full stack. It's a funny one actually, because for a long time I was planning to write a lot about front end kind of test driven development and stuff like that. But because AI is kind of taken over everything now, my workflow has kind of moved more towards using AI and these techniques together. So the key thing for me, though, and something that I should kind of make really clear from the beginning, is that I come from a perspective where I'm used to trusting my tests completely. So for me, that's having really high confidence in the tests themselves. And if something breaks, I should know in seconds. And if I hit a button and the test come back green, I feel like I should be confident enough to do a production release. And that's the kind of mental model that I've had for a long time. So prior to using AI, that is the kind of mental model that I would always aim for. And I've actually seen this in practice many times over. So there's certain kind of specific practices that make the cycle work. So for me, it's things like small increments. So I'm never more than a few minutes away from a working state. That's a mentality that I still kind of keep with AI. I try to have every step kind of in a single commit if I can. I still continue doing continuous refactoring along the time as I'm kind of working on stuff, and I want to be able to improve the design at any point because the tests protect me, and I want to keep that kind of confidence with the AI workflow. So basically, at every step, I know that the code works, and I know that I can refactor with high confidence. Yeah, so the problem that I had was that when I started using AI, or trying to kind of use AI, what I found was that AI was breaking that same kind of level of confidence that I'd had for so long. It was the way that I would describe AI at the time was that it was kind of like an interesting parlor trick in that it was impressive to see and exciting in some ways, but I kept finding that AI would do things like it would go off and do things that I hadn't asked it to do. It would, quite often the scope would just be too great. It would go off and do too many things. And more than anything, I was losing the confidence that I was so used to. If you're coming from this background where you're used to this model where you just hit a button and if the test pass, we're good. And then suddenly I'm in this kind of world where I feel like I've lost control over the code base that I'm working on. And so it actually felt like I was going backwards in some ways. So what I started to do was to experiment a little bit, and this has been for about the last year or so that I've been really kind of experimenting. And what I started to do was it started with just kind of small steps. So I would look at the existing workflow that I had, and then I'd try adding skills around those kind of things and just see what worked and see if if I could actually kind of bring back this control and this kind of confidence that I was used to. And yeah, so the problem that I had was like AI was creating this technical debt faster than humans ever could. So these rules turned out to be the first layer of making it really kind of sustainable. And it was encoding practices that keep the code base healthy over time. And I should be clear that it's not a magic fix. So you still need to occasionally remind AI to follow the rules and things like that. But what I have found is that the baseline is dramatically improved. And what I actually did was at a certain point, I had my dot files. So these are legitimately just my dot files. So there's a lot more in here than just the Claude rules. So, and what I did was I just added these to the dot files, and a few people, I think it started initially on LinkedIn, people were kind of experiencing the same issues and saying that AI just isn't delivering the promise for me. And I just suggested to a few people, have a look at this, try it out, and it seemed to be the case that other people found benefits as well. So it's just kind of grown a little bit from there. But one of the main things that I should point out here is that one of the early wins that I discovered was that by forcing a test-driven workflow, so what I should say, test-first workflow. One of the first things that I noticed was that it had this effect of constraining the scope of what the AI was doing. So that was one of the first kind of wins, because you give it these clear rules. You say, your job here is to start with a failing test, which obviously forces me to have clear requirements as well. I should mention that. So you're forced to have these kind of clear requirements. Start with a failing test. Here is the business logic that you need to write. And your job is to make this test pass, and it would constrain the AI. So the overall plan that I want to do today is I'm going to talk about the key practices and how they work, and discuss those a little bit. We'll have a little look at some of these rules and some of the skills. Then I'm going to give a live demo, and then towards the end, if we've got enough time, hopefully we'll have a little bit of time and we can discuss a little bit as well about a legacy code application, because obviously in the wild, we often work on code bases that don't have this kind of initial setup. So the very first point, and I think this is one of the really kind of core points, is that, and I'll zoom in a little bit if it's not readable, but hopefully it's quite readable. But what I found is that the tests serve as constraints inside this kind of AI model. So on the top, you give the AI a prompt, and it goes straight to code, right? So this is what I was finding initially. You'd ask it to do something, and it will just go straight to code. It interprets freely, might change things you didn't ask for. And what I kept finding was I've suddenly got like 50 files changed and no idea if it works. And find myself almost going back in time to a point where, in the early days of my career, before I really invested in learning skills like TDD, I'd always had this frustrating thing where, the feature that you've just built might work, and that might seem fine, but I always had this niggling feeling, but have I broken two existing features along the way? And suddenly those feelings were kind of creeping back again. So what I found, though, was that by starting with a test, you essentially constrain the scope of the AI, and it understands my job is to just make this pass. The other thing that happens is that you give the AI a way to verify its own work very quickly as well, because that's obviously how TDD works. So I would imagine that most people on this call are probably quite familiar with test-driven development, but again, for people maybe who are not, anybody who's kind of watching after the event or whatever, with TDD, you invert the usual kind of process. So rather than doing the work, then writing a test, and then you're done, you write a failing test first before you've actually written any implementation code, which seems unintuitive, counterintuitive at first, but the point is that what you end up with is this kind of assertion, because you see the code go from, you see the test go from red to green, which gives you this confidence that the thing that you just did was the thing that actually worked, and you end up with this kind of high confidence. But another thing to mention here is that, and this is something that I learned early on in my kind of career, is that good tests have to be written a certain kind of way. And so I also encoded this into the rules, that I don't want to test just the implementation. I want to test the behavior. This is something that early on in my career, I watched this video by a guy called Ian Cooper, TDD, Where Did It All Go Wrong? And in that video, he explains that one of the problems that tends to happen is that people try test-driven development, but they become too obsessed with this idea of what a unit is. And he argues that people often think a unit is a block of code. It's a function, or it's a method, or an object. And the idea is that they end up in this position where they write tests that are tightly coupled to their internal implementation details, and that actually makes refactoring and changes more difficult and not easier over time. So I've long had this perspective where I test behavior, not implementation details, and that has always worked really well for me. So I've just got a really simple example here, but hopefully enough to kind of illustrate the point at a higher level. So in this example, this is a kind of React style example, but what you would be doing here is rendering a form. You would fill in the form, you click a button, and then you basically look for the external effects to prove that that thing has worked. Now, in reality, there would be a bit more setup here. You'd have, maybe some kind of mock service worker stuff going on to mock out the API response or whatever. But the point here is that the test here doesn't know or care about how the internals work. It doesn't know which libraries are used under the hood, any of that kind of stuff. It just knows, given this behavior, this is the outcome I get, and this works. So this is an example here of a test that I'm sure we've all seen many tests like this and probably written some of this kind of style of test where your test is very kind of deeply connected and tightly coupled to the internal implementation details. The problem with this style of tests is that you can end up in this frustrating position where your business behavior can actually work, but your test can fail, and it actually kind of slows you down and can prevent things. Now, to be clear on this, I always think context is king, and there can be occasions where you may find exceptions to these kind of rules. So it's not a kind of religious rule, but as a general principle, as a guiding principle, I think your test should test behaviors. And the kind of key proof to me is that you should be able to change the internal implementation. And as long as the behavior works, your test should pass. And if the behavior is broken, your test should fail. And when you're in that position, even prior to AI, it's TDD just becomes a pleasure when you work in this way, because suddenly you're in this position where you can really change things and have a high confidence. So I'm not going to go massively into all the details on all these skills, but to give you a higher level view, and we'll talk about this in a bit, because you may notice there's a slightly different pattern to this. It's not quite red, green, refactor, but I'll talk about this in a bit. But you can see if you go through these skills that I do talk about behavior and not implementation, and I've got other skills in the background that back all of these things up as well. So as you've just seen there, mutation testing is something that I've added. Now you'll see as we do the live demo that I have mutation testing as a core part of how I work. Now, oh, sorry. Somebody's saying that you can only see the GitHub page. Are you seeing you are seeing the presentation, right? Can you see the presentation?
I can see it fine.
Yeah.
Oh, okay. Okay.
Yes,
we can see it.
yes.
Okay. Just thought I might just be showing a GitHub page the whole time then. So mutation testing is an interesting one. Just to be clear, the way that mutation testing works, this is something that, excuse me, I just need to cough. Sorry, one second. Sorry. This is something that I had been doing for years in a kind of manual way, and it used to annoy people a lot, hopefully in a positive way. So the way that mutation testing works is, if you imagine you've got so you can have 100% code coverage, right? And that's all well and good, and I think there is some value to code coverage, but the problem is that coverage doesn't tell you, all coverage does is it tells you that every line of code was executed during the test run. It doesn't tell you that the test would notice if something was actually wrong. And a test that calls a function but asserts nothing will still give you coverage. It doesn't necessarily give you safety. So what mutation testing does is it asks a fundamentally different question. And it basically says, if I introduce a small bug, so if I change, say, a multiply to a divide, or if I flip a boundary condition or I negate a Boolean, do the tests actually fail? And if they don't fail, then you found a hole, and that's the terminology is that's a surviving mutant. And so the test, so if you have a kind of surviving mutant, it proves that the test it doesn't verify the behavior in the way that you need, and it's a false safety net. So what I found is that more than anything, when AI is actually writing the code, a false safety net is really dangerous, because you're trusting those green ticks to tell you that the code is correct. So what I've done is I created a skill here, and I was a little bit cheeky on this one because there's a mutation testing framework called Striker. I'll show you here. So this is Striker, and what I did was I actually went into the docs here, and inside their docs somewhere there is I won't try and find it now. I think, oh, here it is actually. It's here. They have a whole list of these supported mutators. So what actually happens is in a test framework like Striker, it will actually look at your code in real time. So if you've got some logic that says A plus B, it will run a mutation there. So it will actually inline change that code to become A minus B. Then it runs the tests again, and it will gather up a collection of all of the surviving mutants. So what I did was in this skill here, find it, this one. Oh, sorry, let me find this one. In this skill, I basically took those mutants. So if you again, I won't go through into too much detail, but you can see here, if you go through, you can see the same list of mutants, and then it has all this example analysis, and it basically tells Claude what to do. So it's really powerful, and you'll see that as we proceed. I'll actually demo this. So this is my core loop now. This is kind of what I've evolved towards. So I should make it clear that I still work in these quite small steps, and I don't leave AI to just go off and do 1,000 things at once. Instead, what I do is I have this kind of core loop where it goes red, green, then mutate and fix mutants, fix any surviving mutants, and refactor. And then repeat, right? And you can see here, these are the skills that are linked to. So I've got a refactoring skill as well. The refactoring skill, I'm really quite happy with this one because, again, if you read through it, it does have instructions in here that tells it you don't refactor under all circumstances. You should apply judgment. And then I explain certain concepts to it, how dry works, for example. Like dry to me is one of the commonly misunderstood kind of pieces of advice because people think it's about code, it's about repeated code. But I've always thought that dry is about knowledge, not code, and it's really about what that code is expressing in terms of knowledge inside the domain. And you don't want to duplicate knowledge, but sometimes you can have identical code in two places in a code base, which is actually expressing different knowledge and could divert. So what's quite nice is AI is quite good at factoring those kind of contexts into account. So really important, it still requires real skill, right? The flow that I have, it very much puts the human at the loop. I do verify what's happening quite regularly. One thing that is quite nice, and you'll see this, I'm going to start the hands-on demo in a second now, but you'll see as we're doing this that the green step in TDD is also really quite important here because it gives you a natural point with AI for you to check the code and have a look. What I have found is that over time, I find that I'm checking less. Well, I feel like I have to be less thorough because it seems to improve over time. And when you have kind of good examples in your code base, it seems to get better and better. So usually the checks are very quick now. I guess. So really quickly, I only want to say this really quickly because I want to get onto the demo now, but I need to kind of explain this a little bit to give you some context around the demo and just kind of explain what it is that I'm going to be showing. So there are kind of two extra patterns that I've been kind of working with in a project that I've been working on in my spare time. So one is hexagonal architecture, the other is domain-driven design. It's a lot more than a pattern, obviously, domain-driven design. I'll just quickly explain the hexagonal architecture side of it because then that'll become relevant as we actually move into the demo. So again, for people who maybe not as familiar with hexagonal architecture, the way that this works, it's also called ports and adapters. It's like an interchangeable terminology for it. But the main kind of insight on hexagonal architecture is that you end up with this setup where your domain logic lives at this kind of core. So there you can have kind of pure functions and entities, value objects, that kind of thing. That your core has no knowledge of any external factors. So it doesn't know what database you use. It doesn't know what APIs you use and so on. So I'm using Next.js in this app that I'm building, but the core of my domain logic doesn't even know. Not only does it not know about Next.js, it doesn't even know that it lives inside a web app, for example. Now, what I've done, let me just show you here. So the way that it kind of works is that whenever you have an external um, any kind of external influence on your system, something like a payment provider, for example, it's all done with adapters. So what you do is you have these interfaces in the core of your code, and then you expose these kind of the functionality through adapters. So and then the adapters become swappable. So what I'm going to show here is the demo is going to be taking this newsletter port, which is an interface into the system. And let me just show, I should have it running. So if I run here, this is running locally. So basically what I have right now is I have this setup where, so I have a kind of newsletter provider here. And let me just show you here. If I just log into this system, so I'm using right now this system called kit.com. So if I just log in, I can just quickly show you here. If I go to subscribers, if I go in here and I just type in Paul at testing 123, hopefully this will work. Do that, and then if I just refresh the page here, and you can see here, I don't want to show all the email addresses that I've got on there. Some of these are real email addresses, but you can see here I've got Paul at testing 123 has just appeared here, right? So what I'm going to do in this demo is I'm going to change the payment provider to be a completely different provider, and we'll do this live now. So what I'm going to do is just give me 1 second. I've got this is hopefully you can all see my terminal, right? Is that?
Yep.
You can see.
Yep, we can.
Okay. So yeah, if you just give me 1 second, I've got a prepared prompt for this, and I'll share the prompt in the chat as well, so you can all see it. Let me just grab this. So I'm just going to paste this in, and while that's working now, I'll just leave this running in the background. We'll keep coming back to it so you can see what's going on. I'm just going to paste the prompt in so it's fully transparent. You can see everything here. You will notice that I have said in the prompt that it's a live demo. I've actually explained this to Claude. And what I've said to it there is when you run mutation testing, present the results as a clear, readable report. Now, actually, it's supposed to do this by default. But what I found is sometimes you just have to kind of remind it. So what I've done is I've made it really explicit in this prompt. So what it's going to do now is it's going to use this plan skill. So let me explain the actual prompt that I've put in here. So what I've said is build a reusable button-down newsletter adapter for the micro SaaS framework. So let me just show you in my code. I can, sorry, 1 second. Why is my Chrome not showing? 1 second. That's a bit. I don't know what just happened there. I seem to have lost my tabs. But let me just quickly show you here. If I go into GitHub while this is running in the background, so just to show you some of the code here. So this is what I'm actually working on under the hood. It's an application, but it's powered by the framework that I'm building, right? This micro SaaS framework. And the idea behind this is that ultimately what I want to be able to do is to create SaaS products really quickly. And so the idea behind it is that if I just go in here, I can show you packages, and I have this core here. So when I talk about hexagonal architecture, everything inside this core is, the way I describe it, is a capability. So you can see here, and these are exposed by interfaces. So if you just see here, this is just a very simple interface. Some of them are a lot more involved than that, but this is a really simple one that I can just use for the demo. So the idea is that my internal kind of domain knows that it's dealing with a newsletter, but it doesn't know the specific provider. And each one of these interfaces, you can see they get more complicated. Like this payment port here is obviously much more complicated, and this works right now with Stripe. But the point is, though, that I can tell it. So if I go up a level, 2 levels, sorry, you can see here that then I have these kind of adapters that implement these interfaces. So I've got Kit, which is the one I've just shown you there, kit.com. And then I've got a MailChimp one because I demoed something previously in the past which used MailChimp. So what we're going to do now is we're going to build a new adapter and then plug it into the system and see that working. So that's going to be for a service called Button Down. So let me show you this. So it's just a newsletter provider. And I signed up for this yesterday, so should be able to log in. So I needed to get an API key. So you can see here, I've got subscribers here, and it's all kind of empty right now. There's nothing in there. So what I'm going to do, so what I've asked it here is I've already done some kind of prior analysis so that this is ready to go. So I said, build a reusable button-down newsletter adapter for the Microsoft framework, then integrate it into Chipping, the app. A bit of instruction here about like how this needs to work, just a standard kind of prompt. Now, what it's doing here is it's building. So the first thing that it's going to do is it's going to build the. It should build a plan. Yeah. So it's you see here, create the PR with just a plan for the review. So I'll ignore the PR that it's going to create. I just want to see the plan. Hopefully, it's not going to take it very long. But once it creates the plan, what it should have. Oh, it's running. I'll tell it to skip this in a minute. These are all my front end tests, which it's running now because it's got it's got a hook in there, so it's got a commit hook. I'll tell it to it's running those in the background. I'll just tell it in as you continue. For the purposes of a demo and time, please do not run the verification step on commit. Obviously, I would never normally tell it to do that, but that's just to save a bit of time as I'm demoing. What it should do, though, it's going to use my plan skill. And one of the things that the plan should do is it will be very explicit about you've got to use this red, green, mutate, refactor every step of the way. So if you give it a moment, I'll show you this plan as it's created. As this is working now, it might be a good time to answer any questions if people have questions as this is going. Don't know if there's any questions now. If there aren't any questions, that's fine. I can just carry on. It's just obviously takes a moment.
There are some hands up. Sorry to interrupt you.
Oh, sorry, I didn't see that. Yeah, sure.
Go ahead. Did you have a question?
Yes, I did. So one question I had was, so earlier when you showed, so this is, I just have some confusion regarding the point in your slide earlier where you showed that a good test is an acceptance test that's just checking some behavior and some output instead of asserting on the implementation. And in the bad example, I could see that the code was asserting in a method was called using X argument fashion. From the art of unit testing, I remember like the author says that there's 3 outputs that you can assert on, one of which is like any outgoing dependency. So one is internal state, one is some result that is written, and one is outgoing dependency. So consider the unit that you're testing, the system under test, the whole expected behavior for that unit is just that it should make call to some external dependency and we want to assert on that. In that case, if you're writing a test that's asserting on outgoing dependencies, would you consider that implementation detail test? Like I'm just trying to reconcile that part with the kind of tests we write for, let's say, a service that makes call to some external dependency.
Yeah, so this is the thing. This is why I say that it's not a kind of religious rule, right? And the context is always king to me. So if you have a good reason to kind of violate that rule, if there's a really good reason for it, then I think it's okay to do that. But as a general rule, as a general principle, the way that I try to look at it is, would these tests help me to make changes over time? You know, do they actually help me to make changes? So where I kind of does that make sense?
Yep.
Sorry.
It does.
Yeah. So I try to not have those kind of implementation detail tests unless I really need to, but there are sometimes contextual reasons that make sense. If I can just quickly find here, sorry. So it's created a plan for me. I just normally it tells you the name of the plan. Where's it put that newsletter markdown? So let me just find the plan. So I'm just going to share my screen. Share my IDE. Just 1 second. So I think this is what it's created. So as you can see here, what we have. So the plan here, it starts off with these acceptance criteria. And then what you should see is that it breaks it down into these smaller steps. And you can see that each one of these steps has a red, green, then a mutate, then kill mutants kind of structure. What I'm going to do, just for the sake of time, I'll tell it to continue, just so you can see. Now, what I would hope that it will do now, and hopefully you'll see this, is that you should see that it starts to go through this that pattern, red, green, and then mutate. And what you should see, hopefully, is that it will show you a report at each point, and it should tell you what mutants survived, and what it's fixed. One thing that I have found that is quite nice as well is that again, there can be sometimes contextual reasons as to why a surviving mutant might be a red flag. Sorry, might be a red herring. It might be something that actually, under certain contexts, actually isn't as important. And AI's got, I've kind of put rules in that to ask the human under that circumstance, does this thing actually matter or not? Hopefully you'll see this working. I did this full demo previously to test it out, and it all worked perfectly well, but hopefully hopefully you see the same thing here. But what you should see as well, it should ask me fairly soon. It shouldn't go too far. You can see here as well, if you see the output here, so it's clearly saying that now it's in the red phase, so write the failing test. And again, another thing that I should mention, and I'm sure people on this call are fully aware of this, but again, just to be really explicit about this, TDD, when done properly by a human, is always one test at a time, right? So you get yourself into this really fast feedback loop, and it's really valuable, and it's always one test, right? But what I found with AI is I experimented with this a bit, and I initially forced it to go one test at a time. And while that does work, it's quite slow. And what I found was that really I probably should rename it to test first rather than TDD strictly, because it's not, because the way that it tends to work is it will write multiple tests in a block, but they're all related to the same behavior. And it seems to do a good job of, it seems to still work for the AI, and that works quite well, and it still constrains it. You can see here, if you see, I've got mutation testing report. So it's actually, it's found 5 surviving mutants, if you see here. And it's saying they're all in this fallback error path. So can you see here, though, this is telling me, see, it should already have 100% coverage, right? Because I have that enforced as well. Now, just for time here, I don't know if I've got enough time to kind of really prove, that it's got 100% coverage, but you see this all the time where you have 100% coverage, but it will find things. And you can see here, look, it's no test exercises, a non-201 response, and so on. Now it's saying here, okay, it's also able to apply judgment. So that is going to happen in the next step. So what I would normally do here, let me just show you. I would normally go through, and at this point, I would take a look at what it's done. So you can see here, you've got these tests. Now, this again, to show you kind of, maybe this helps answer some of those questions as well. So the question from before, the way that this works here is under the hood. Obviously, I have to call this API because this is the button down API. There is a mock here using mock service worker, but it's not asserting, we call this internal method or that kind of thing. It's just saying, given that I set up this adapter and I call this method, when the button down API returns with such and such a thing, I get this result. And that's the way that these kind of tests are written. Now, normally, under normal circumstances, I would go through and check. Oh, sorry, it's a bit of noise in the background. I would check each one individually at this point, but you can see, hopefully you can see that it should be a relatively quick thing to look through. And usually, to be perfectly honest, I tend to focus more on the tests, and I go through at a fairly quick speed. What I'm going to do here, because it's a demo, I'm just going to say, for the purposes of this demo, go through without asking me for manual verification now, but continue to output the mutation testing reports as you go. So I'm just I'm just doing that to speed it up. So hopefully we can see a working example at the end of it. Hopefully it's okay. But you can see here hopefully how this works. And one thing I will say is that this mutation testing, it's really revealing at times. There are times when you can manually, do a code review. You can go through and you can have this high confidence that you think everything works, but then you'll sometimes be surprised at what it finds. So I'll let this continue in the background. Sorry, I see another hand. If you have another question.
Yeah, actually, I had raised my hand earlier, but I can present my question, but feel free to take it up later, Paul. I wanted to check if you have tried spec-driven development and how this workflow compares to spec-driven.
Yeah, so it's a funny one. I haven't actually explicitly done that myself because I kind of just started on this journey myself a little bit before spec-driven development maybe was, I don't know if it was a thing or whether it hadn't really been popularized at that point. And so I started just kind of doing it this way and saw it working really well for me. I'm going to tell it to do this no verified. It'll take ages if we have to keep doing this. Sorry, just 1 second. But my understanding is of spec-driven development, and I could be wrong about this because I haven't got into it in massive detail, but my understanding is, from what I've seen, it does seem a bit more kind of big design up front. And again, maybe that's not the case. Maybe it's changed a bit. But when I did look at it, it seemed a bit, to me, like you have to get the design pretty accurate up front. It has to be pretty much there. Whereas the way that I kind of like to work is in these small increments where you get feedback. So I like technical feedback for me is, test-driven development. Are the tests telling me the right thing? But also feedback from, ideally from users as well, where you could, you can actually see whether people are using your application in the way that you would expect, and basically given that feedback, you adapt if that makes sense. So the way that I prefer to work is in these kind of smaller increments where you test something, you see if it's working, and you change direction. In terms of spec-driven development, it's one of those that I haven't experienced it properly myself, so can't really comment too much other than to say that I'd be a little bit skeptical of approaches that are quite, that expect you to have a perfect design up front. The way I quite like to do it is to evolve along the way. So even when I'm doing this, what I would normally do is stop at certain points and see how it's working out and maybe change the plan as I'm going. So I don't know if that fully answers that. I would say I'm not explicitly using any spec-driven frameworks because I've just found that this flow works really well for me. And on top of that, I will say that it's been working very well in real kind of client-facing production environments where we've been able to kind of continue working with this really kind of high level of confidence. I'm lucky enough to be working right now on a code base that was originally built without AI, but using test-driven development. And so I'm quite lucky in that regard. Maybe while this is going on in the background, I could quickly talk about legacy code if that makes sense, just to fill the time while this is doing this. I'm just going to tell it here. Sorry, please do not use please use no verify or committing. Again, I would never normally do that. I'm just doing that because just to help the speed with it. Yeah, if I just let me just come back to my talk for 1 second, because while that's working in the background, I just wanted to mention, I guess, one thing that is hopefully useful, which is this slide, because this I think is quite important. Is if you don't have the existing kind of setup, which is most organizations in my experience, not necessarily you don't have tests, but maybe you feel like you can't trust the existing tests. There's a book that I'm sure a lot of people in here are very familiar with, which is Working Effectively with Legacy Code. And it actually, I felt like I joined the right organization here when we went on a prior call about this. And I think it was you, Siddharth, you said I can't remember. You made a seam joke, and I thought, okay, yeah, I'm in the right place. But for people, again, maybe if you're not familiar with this book, it's a really good book, which I'd recommend reading. It's a little bit old now, but it's all based on principles, and the principles they still apply. And I don't have a huge amount of time to talk about this one, but I have added some skills recently, as in very recently, mostly triggered by this talk, if I'm honest. But they've been added, as you can see here. Like I updated it just before this talk. But what this book talks about, I'm just going to check in the background. Yeah, still going in the background. What this book talks about is how to work with legacy code, and it defines legacy code early as code that just doesn't have tests, or where you can't trust the existing tests, right? So his definition, I really like this definition, because he's effectively saying, if you write code today that isn't covered by tests, you've just written legacy code, right? And in the inverse of that, if you're dealing with code that was written 20 years ago, but that code has really good, well-written tests that you can trust, those tests are not considered to be legacy code, right? But he also creates these. He has these techniques that. Sorry, I just want to make sure I've got my speaker notes here, so I don't miss anything that I want to say. But he has these techniques that he recommends that help you to, if you're in that situation, to incrementally improve the code base so that you can start trusting the code, right? So two of those techniques here, the one called seams and the other is characterization tests. So I've extracted both of these as separate skills. The idea being that you could use them to help you if you needed to. So a seam, so the problem is that you need tests to refactor safely, but if you're in a legacy code base that hasn't been written with tests in mind from the very beginning, let me just keep this going, that hasn't been written with tests in mind from the very beginning, you can end up with this kind of chicken and egg kind of problem, because you need tests to refactor safely, but the code itself is written in a way that resists testing. And so seams are there to it's a technique to help you break that cycle. So it's a place where you can alter the behavior without editing in place. And it has kind of two purposes, as to my understanding. So one is that helping you to sense and observe what the code does, and then separation, so separating the code and being able to run that code without real dependencies. You can extract interfaces and inject a dependency and break the coupling and that kind of thing. So AI is really good at this kind of thing. And so what I've got is the idea behind this this skill here is to have AI help you to find places in the code where you could find a good place to find a seam. So again, if you're in this kind of legacy, code base where you don't trust the tests, you can use this this skill to help you find a place where you can kind of start to progressively improve the code so that you can build that confidence up over time. And the other skill that I've added is this one, characterization tests. And these are quite interesting, I think, because it's the complete opposite of everything I've been saying so far with behavior-based tests. What you actually do with a what you do with a characterization test is that you write an assertion that essentially what you're trying to do is to prove what the code actually does right now. So there's a technique around that, how to create this kind of safety net. And these are supposed to be the not permanent tests, the temporary scaffolding. But what's interesting here is that you're supposed to just lock in what works right now, even if you detect a bug along the way, you effectively keep these tests in place that would actually lock a bug in place temporarily, if that's what you found. The idea being that it helps you to have a way to know when you're moving away from the current behavior, and it helps you to try and kind of work out what that original behavior was supposed to be. So again, these are things that I would recommend if you don't have existing tests that you can trust. You can see here now that as it's been going through, so it's managed to kill a bunch of mutants. You can see here killing mutants. If we go through and let's just see what it's actually found. So, because sometimes it's quite interesting here, and it'll say every single mutant has been killed. Let's see what it actually discovered. Hopefully up here it'll tell me. So yes. Oh, so I think in this instance it was planning to kind of kill those mutants as it went. If they were just missing tests at that point. Sometimes you get really interesting stuff here where it finds a genuine potential bug. But we'll see what happens here. Hopefully this is going to finish in time and I'll be able to show you this working end to end. Yeah, I don't know if there's any other questions at the moment while we're just waiting on this. The other thing I guess that I wanted to that I was going to kind of mention is again, I don't really want to kind of go too far into it, but I've been kind of experimenting a little bit with domain-driven design. And one of the things that I did here, I'm just going to explain this while this is kind of running in the background. But I have this kind of, let me just quickly show you. Sorry, if I just go to my repository here, let me just create a, if I go here, I've got a shortcut, you can take me straight to it. Yeah, so I have inside this application here, this one's just an interesting one just to kind of mention, I suppose, while we're just waiting for this to run. But inside the application itself, I have this domain folder, and I've been kind of experimenting a bit with domain-driven design here. And one of the things that I found quite interesting was if I could just ask AI to analyze that folder and tell me what it can tell me about my application just by looking at the code inside that folder. For some reason, I seem to keep losing my presentation. I don't know why. Let me go back to it. So one of the things that I asked it to do there was to just build a visualization of like how my code works under the hood. And you can see here, if I hover over any entity, you can actually see that it shows you the relationships between these things, which is quite interesting, I thought. So for example, there I've got, if I've got a savings goal, you can see that it relates to occasion, it relates to user events and money. Again, I maybe won't go too much into that. It's not really the main theme of this talk, really, but I just thought it's quite an interesting thing to mention, I suppose. So just while this is continuing, sorry, 1 second. Yeah, so it's still going. Hopefully we'll get there. Is that still continuing? I don't know if that's, you know what, I'm going to just tell it to continue there. It looked like it had frozen for a moment. But hopefully we should get to a point where I should be able to integrate this, should be able to go here. And all being well, when it's done, if I type an email in there, what should happen is it should come out the other end into button down, and hopefully should just work. Yeah, I don't know if there's any other questions that people want to ask while we're just waiting on this, or we can just continue as it's going. But hopefully you can see the flow here that, you know, as I say, if I'm not demoing, I would be going through and checking, you know, each commit point. But as I say, it's very, it tends to be very fast as I'm doing this. So don't really spend too much time doing that. Hopefully the demo gods want to play nicely today, because as I say, I tried this last night and it worked first time, but it seems to be taking its time right now. But we'll see. Hopefully we get there. I guess in the this is actually let me just see. I think this is actually integrating it right now inside the Chipping app itself. So it's coming to the end now by doing this. So this is actually because if you remember, I've got like a core framework, and the idea behind that framework is that I want to get to a point where, you know, in the future, I can just say, okay, I'm going to build a new SaaS application, and I need, you know, payments, newsletters, emails, and, you know, different types of notifications, and I just pull in the adapters that I want, and it just works that way. So what it's now doing, it's just by seeing this, I can tell that it's got to the point where it's built the adapter, and now it's actually integrating it into the specific application itself. So hopefully in a moment this should work, and I've already got the API key ready because I did that yesterday. So hopefully this should work. You should be able to see it end to end. I can see a question there. Sorry, what does this say? How do you? I'm trying to click on it, but it's not letting me. It says, how do you decompose your work? But I'm trying to find where that question was. Is that right at the top? Oh, hang on. How do you decompose your work and triage it now when using LLMs to power the engineering? So a big part of that is maybe I skip through it a little bit. I have a planning skill here, and I'm sure like there are lots of planning skills out there now, but the planning skill that I've got, let me just show you that. Sorry, go to the planning skill has instructions in it to break down the work into these kind of smaller known good increments. So that's what I use. What I would say with this stuff as well is, a lot of it is trial and error, and it's just me it's just me trying stuff out and seeing what works, seeing what doesn't. And it's I'd recommend to people, if you're going to take a look at what I've got, have a look at integrating it obviously with your own skills and your own ways of working, and see what works for you. But for me, this has been a flow that it's helped me to not only work well with AI, but to work in this sustainable way. And that to me is really kind of key. And it's where things like mutation testing, I think, show real value, because I still want to be in this position where I have this really high confidence that stuff works. And if I don't have that confidence, to me, it's like, it's kind of unthinkable to be in a position where I have to go around and, manually click inside an app to get the confidence that things work and stuff. I want to hit a button and have an easy life. I want to live that dream. And it's, these techniques have certainly worked really well for me so far. And to be clear, when I'm not sure, sorry, who it was, but when somebody asked about the spec-driven development, as I say, I personally haven't tried it just because it's continued to work really well for me. And again, my answer to that you might find that maybe it's not a fair answer anymore. I don't know, because when I did look into it, spec-driven development just looked a bit too big design up front for my liking. Again, you may find if you read into it now and maybe you've been playing with it, maybe that's no longer accurate. But that's kind of what put me off trying it at the time, I would say. So hopefully that's fair. So hopefully this will work. This is just sod's law. It did it in about 15 minutes when I tried it yesterday. But let's see how this works. It's still okay. So it looks like it's still trying to get the actual adapter to integrate with the app. Again, to be really clear and just to be really explicit, in this demo, I'm obviously letting it skip through, and I'm not stopping at these steps, but I would be doing that just to check. But to be perfectly honest, as I said before, at least on a code base where you already have these rules in place, you've already got good examples, it doesn't tend to make many kind of glaring mistakes. And it's another thing I would say is that having an architecture in this instance that has specific rules around it. So if you're interested in the hexagonal stuff, I have a hexagonal architecture skill as well. I don't enforce that. If you read the skill, it actually says that many code bases don't use this pattern, so you don't have to use it. But if the code is using it, then the skill should kick in and should load. But what I have found quite interesting is that when you are using a known architecture like that has a name and explicit rules, it seems to play really well with AI, because hexagonal architecture has rules around the direction of the kind of direction of how a kind of request works and what knows about what. So there are explicit rules. This is getting right to the end now, I can see here. But this is there are explicit rules like your domain should not know about any frameworks and that kind of thing. So AI seems to play really well with that kind of structure, and there are rules around where code lives and things like that. And again, just having those rules in place, I think, seems to help AI quite significantly. But again, to be clear, if I were working on a legacy code base now, I would be, again, if there are places where you can't trust the code, I would be looking at those places, and I'd start kind of small rather than trying to get AI to run at 100 miles an hour, I would actually go a slightly different way. And I would say to it, okay, what we're actually going to do is try to make try to get ourselves into a position where we can start trusting the automation, right? Because AI obviously full automation. I want to be able to trust that, these tests are good, and I would be going in and running these mutation tests. The mutation testing, if you run Striker against your entire code base, it's really slow because of how it works. But if you're clever about how you do it, and you maybe get AI to look at mutation testing only in the area that you're working in now, you can start building up that confidence. Combine it with those, the seams and seam skill and characterization test skill, and I think you can start building up that confidence, and then start running this kind of flow. So there's one failure left. Let's see how we go. I can stay a bit later, so hopefully we'll see this working end to end. Yeah, I don't know if there's anything else that people want to ask, or if there's any. Oh, I saw. Sorry, I just saw a screenshot there. SDD feels like big design up front sometimes. Yeah, that's the impression that I had. But again, I do want to be clear that, I could be wrong about that. But that's certainly how I read it. Yeah, and the point here, yes, Siddharth, the point that you made there can be bounded at architectural boundaries. So I think this is a really good point about, again, things like hexagonal. One thing that I asked, I tried to ask AI at one point. I gave it like a fresh agent, and I asked it, be ruthless with me and tell me, this architecture that I've got, is it actually useful? Is it overkill? Am I over engineering this kind of thing? And it actually came back, and one of the things it said was that having the architectural style and having a domain that is isolated from everything else helps it to reduce token usage. It actually did say that because it doesn't have to scan. It can quite quickly focus on specific things. So I'm seeing here I've collected questions for you. The only issue I've got, Siddharth, I'm trying to click the questions, but it's not taking me directly to them when oh, sorry, I see there. Yep. So, okay. What is the benefit of mutation skill? Right. So that one's a really interesting one. What is the benefit of in using a skill for mutation testing over Striker directly? So, funnily enough, if I'd answered that just a few days ago, I would have probably given you a slightly different answer to that question. So, the reason I created a skill initially was because whenever I tried to use Striker, I'd always found it's very powerful, but quite slow was what I found. And on a large code base, it can literally take hours to test. So what I wanted to be able to do was to have an easy way to just kind of do it in line, and to use AI to kind of do that for me. But what I actually tried just a few days ago, funnily enough, was I thought, you know what, I'll see if AI can help me to get Striker into the code base directly, and to have it work in such a way that it only runs against the changed files. And that's actually the setup that I've got now. So, but that's something that I've only done in literally the last few days. But just to show you, if I get my code up, I'll show you how that works, because I did notice when it was doing this a minute ago. I'll just open up my IDE here. You'll see that I do actually have these. Let me find. Yeah, can you see? So this is the folder that it's created, and it has created this Striker config. Now, I didn't mention this explicitly on the call because this is so new to me working in this way. Literally only done it in the last couple of days. But I've actually found that this is working really well, and actually is faster than using my agent or my skill. But the one thing I will also point out, and what I'm probably going to do quite soon, is to change this skill to basically tell it, aim to set up Striker in this way, so that you can use it in this kind of incremental way. But if for any reason you can't set that up, or there's rules against it in a place, just use the skill. But I will say that I think there's still an advantage to having the skill. And the reason for that is because, sorry, that one, is because what you find is it will, as it's writing these reports and stuff, it helps you to apply judgment. So it can feed back and it can actually say, okay, not only to apply judgment, sorry, but also it will look at the behavior and it will say, okay, I found this gap and the test that I need to add to fix that gap is this. And it's really good at that. And what it tends to do is it'll say, because I've got all these rules about business behavior, the test that it adds will often exposes a missing business behavior. So hopefully that makes sense. So what I would actually say to that is, like if you look at that skill in a few days, it'll probably be changed to recommend implementing Striker directly. So it looks like this is done. So let me just test this now. So what I'm going to do, hopefully this will just work first time. So I'm just going to, I'm rerunning because I have environment variables set up for this. Let me just check that the environment variables haven't been, well, I'll soon see if they've been overwritten. So let's just see if this works. And if it doesn't, I'll quickly look at the environment variables. So that's my, this is buttoned down. If I go in here now and I just do paul@testing.com, hopefully. Okay, did that work? Let me refresh. Hey, there you go. And so that's now worked and pointing at a different, different service. So hopefully that gives you some kind of insight. It is a bit difficult to do it on a call with, limited time, because obviously have to speed through it in a fairly quick way. And I'm trying to kind of do it live as I'm discussing these things. Let me go through the rest of these questions. So any tip for teams that work on tech that doesn't have a lot of support for mutation testing? That's an interesting one. I guess my background is very heavily kind of web-based, so I'm kind of used to working in that domain. If you don't have, so I guess one thing to say there is that I would encourage experimenting. Again, I come from this kind of background, but maybe if you're working in a background that's completely different domain, one thing I would recommend is if you actually use Claude, you can ask Claude these things, right? So I would say, again, say if the domain, I don't know, let's say it's robotics or something like that. I'm just guessing here, right? But let's say we're in robotics and I don't know, this domain just doesn't have that kind of support. There's no existing framework for it. What I would do is I'd literally take Claude, I'd use the Claude skill writing skill, and I'd basically say to it, look, here's mutation testing. Go and look at Striker. Scour the docs, understand what it is, and can you help me to create a skill that would actually give me some of this, this capability? Because you can ask. So what you've been seeing here is you're seeing Claude actually using Striker under the hood. But if you use the pure skill itself, it does work. It's a bit slower than using Striker in this way, but it does actually work. So I would say you can ask Claude if you can basically feed it that capability and experiment with it. And don't be afraid to experiment. Like all the stuff that I'm showing you here is just stuff that I've kind of experimented with myself. And, in a couple of weeks even, I might have changed some of this and some of the way I'm doing it. So just experiment is what I would say. So how do you decompose your work? I think I answered that one before. That's basically using that planning skill. How would we ensure the quality of the test? AI does not understand the boundary properly, and even in behavior tests, there will be some kind of boundary that will require mocking. Yeah, that's a really good question. So I think I do have skills that specifically talk about testing, not just so I think I've got like front end testing here. So that goes into detail about like specifics around front end testing. But then I think I do have one that's just about testing. So there's React testing. And then I've got a test design reviewer as well. What I would say is, so have a look at some of these skills, because I've got skills here that help you to review the tests as well, but also apply human judgment and, understand the context that you're in, understand like what is the value that I am trying to get out of this test. Don't just religiously follow a rule. Like the reason that I say I want test behavior and not internal implementation details is because the mental model that I have is that even prior to AI, the way that I would work when I'm not using AI, right? So I would usually I work on a big widescreen, right? So that helps. But I would basically have, I'd have my terminal like this, and then I'll have, it would never be on such a small screen like this, but I'd be doing it like this, have my code on one side, have my terminal on another. My terminal is running tests as I'm, it's always in a watch mode. This is pre-AI, obviously. But what I want is, so at the moment I would hit save here, the test would run, and I want to be in a position where the test pass if the behavior works, if the app is in a working state, and they fail if it's not. And as far as possible, the test can help me make changes over time. And that to me is the key mental model that I have. And so that's the kind of model that I go with when I'm looking at tests. Like, do the tests help me to make changes, or do they get in my way? So I would suggest, again, you're going to know your context better than anybody else, but try to have that kind of model in mind. Do these tests actually help? Are they actually spotting things? If I refactor the code so it works, but I change the internals, so I'm using one library over another, or I call a different method, do my tests still pass? If they fail, is that really helping me at that point? Yeah. Do you use AI to help with deployment of CI/CD as well? Yes, I do. Let me just quickly show you this. So CI/CD. So I'm actually, funnily enough, for my own thing here, weirdly, I'm not using GitHub, but the reason I'm not is just because it's just to save money, literally to save money, because I'm running, this is on my own home lab. Oh, for some reason it's not letting me log in. That's weird. We'll do that again. I've got a YubiKey, you see, so maybe I didn't do that. There we go. This is literally just to save a bit of money, because I was using so many minutes in the GitHub Actions that it was costing me money to do it on this closed, because this is closed source, this particular one. But the way I've got this set up, it's the same kind of setup. It's pretty compatible with GitHub Actions. And the way that it kind of works, it's I do continuous deployment actually, and I've got a full setup here with ephemeral deployments. In fact, I should be able to show you. So this one here, it's something's failing on the PR itself, but I should be able to show you here. I've got an ephemeral deployment here, and yeah, there you go. And you can go to this now, but I'll close the PR shortly, and that'll actually destroy that. But I put it in the chat, you can quickly see. And it also has, you can see here, it'll set up a test user and a test password for me. It does all of that stuff for me. And Claude was a massive help in that, I should say. The way that works is under the hood. So I use Cloudflare to deploy and to host, I should say. But I'm also I use Authentic for my auth. So this is it's an open source identity provider. I use this. And I also have, a database and so on. And under the hood, I'm using Terraform and Docker. And what I do is on each PR, it creates a full ephemeral deployment that in Cloudflare will create a. I'll quickly show you. I can log into Cloudflare. This is all done with the help of Claude, and honestly, Claude was amazing for this. I'll just quickly log in here. I can show you this. If again, I need to use my key. 1 second. It should ask me for a. Yeah, there you go. Seems to be having a problem with my YubiKey for some reason. But I don't know why it's not. Oh, hang on, I've got one. I have a couple of YubiKeys. So let me just try that again. If I do, there we go. Second. But I just want to show you here, because it will create the ephemeral database for me, connects all that up, and it even adds it adds users in the identity provider using Terraform. It's quite an advanced kind of setup that would normally take quite a lot of effort, to be honest. And Claude was just amazing at this. So you can see here the way that this works. So there'll be a PR number here, 278. And you can see I've got FJ, because FJ stands for Forjo. That's what I'm using, because I also have it also works on GitHub, and then it'll be GH. But I'm just trying to save a bit of money because I'm cheapskate. But yeah, hopefully that helps explain that. But it's a full, for my pipeline as well is always, my preferred way of working is continuous deployment, because I think you should trust your tests so much. A merge to main goes to production. That's what I like to do. So that's what I'm doing. Final question there. If all the good design skills are loaded along with the skill for testing behavior and not how, does it matter if AI is done TDD or not? What additional benefit does? Yeah, so it's a good question. And to be honest, like even though I've done TDD for so long, I would be happy to change that flow if I didn't think it was giving me the benefit. What I would say is that I think that these kind of three things that I think a TDD flow, I should really call it test first, really, because it does multiple tests at once. But I think there's about three things that I would say it helps with. So the first is it constrains the scope of what you're doing, of what the AI is doing. I think that's quite important. Every time I've tried to go without it, I just see it doing too much. It goes off and does stuff that I didn't ask it to do, and I don't like that. And having this explicit rule, your job is to make these tests pass and do nothing more than that. That seems to really help constrain the AI. The other thing is that it gives it an instant way to verify that what it's just done has worked, because you force it to go red, green as well. And by forcing it to do that, it gives you at least some confidence that that connection can be trusted to a point, right? And I say to a point because I still don't fully trust it. It's why I added mutation testing. But I think that helps. And the third is that you should end up with this kind of full regression suite. Like I have 100% test coverage for everything. And because I'm now doing mutation testing as well, I have this kind of 100% coverage and really high mutation testing scores, which gives me confidence. I will say, again, it's hard for me to think of an example off the top of my head, but there are some occasions where you will find a surviving mutant and you can just apply judgment and say, actually, that thing isn't as important as you want, as you think. So I think one example I had of that a while ago was some styling logic that I had. And I didn't care about about that one. And there's a few little things like that sometimes you just apply judgment. But I would say, again, with this stuff, experiment with it and just see how it goes for you. The flow for me has worked really well to give me this confidence. And I will say that we've been doing this in the place where I'm currently contracting at now. And if it gives you any kind of confidence at all, for the first time in my whole career, 20 years doing this stuff, the first time in my whole career, I had a product owner come to me at one point. I think she was semi-joking, but like still, I couldn't quite believe she said it to me. And she said, can I just have a word? And I was like, yeah, sure. And she was like, just, you guys do really well with AI, but could you just maybe slow down a little bit? Because we're going to run out of work to give you if you don't. And I was like, that's not a conversation I've really had before with a product owner. And I see that as a sign that, we're doing something well. I guess one thing I will just add to that as well, and I think this is an important one, is that, there's a lot of fear around AI right now. And obviously I don't have a crystal ball. I don't know exactly how things are going to pan out. But my own perspective on this right now is I don't feel right now scared that my job is under threat, because you can see from this flow, and I know in this particular instance, I had to pick an example that would be relatively trivial so that I can show you, in a live code example, right? And also I'm speeding through it in a way that I wouldn't normally because it's a demo, and if I go through it, it'll take me a bit longer. But to be clear, it's the way that I work with AI. It's very interactive, and it does require a human in the middle making these judgment calls. And it's like I say on one of the slides I've got, I think, you very much still need skill to pull it off. And to that end as well, I would also suggest that, people who may be a bit less experienced with extreme programming style techniques, maybe take a bit of time to read up on those and play with them outside of AI, just to help you with that mental model of kind of what good looks like. Yeah, hopefully that makes sense. I think, have I covered all the questions? I think I have. I don't know if I've missed any.
There's a hand up,
Just a
but I think
follow-up.
you've got, yeah.
Just to follow up on the same point about like using TDD with AI, Paul. So, since all of this is happening within the context of the conversation that you're having with, let's say, Claude, in this example, uh, how do you see it impacting the number of tokens used and driving up the cost? Because if you're continuously running your test suite again and again, it can just eat up those tokens, right?
Yeah, I mean, it's a good question. My understanding, though, is when you run the tests directly, I don't think running the tests will necessarily use up too many tokens because my understanding of how it would work is it will just read the kind of output at the end. But I would say, to be perfectly honest, I mean, for me, in my own kind of time, because I am kind of building stuff, I've gone in and I'm paying for the more expensive Claude model. So if I'm being honest about that, I haven't massively taken into account like how to kind of make it the most efficient way possible, if that makes sense. It may be that you could improve things in that area. I will say that as I kind of mentioned before, the kind of hexagonal approach and domain-driven approach does seem to help. Well, I asked AI directly about this, and it fed back to me that again, whether you trust it or not, I don't know. It's not the most scientific thing, but having those kind of rules and kind of structures in place, I think does help because AI doesn't have to read, it doesn't have to scour tons of business logic that's kind of all over the place to try and understand that story. In terms of TDD, I would expect that it probably doesn't increase the token usage too much, but for full transparency, haven't actually experimented with that myself, so I don't know. If you find that it is causing issues in that area, again, what it's become my default now is to kind of speak to Claude about it and ask, how could I improve that? Do you know what I mean? And you might find ways to improve. And, if you do find ways to improve, that's it's a really good thing. And you can always share that back with people as well. And, I'd be interested in that as well. Yeah. Cool. Yeah, I think that's everything. Hopefully that helped, and I think I've answered all the questions. Again, if there's any more, I'm happy to answer them. Yeah, but I guess the final takeaway thing I'll just say, just experiment yourself. I mean, it's a very new space. Like nobody's really an expert at this right now. I'm just feeding back what I've been experimenting with. I found a lot of success with this kind of way of working right now. My way of working is evolving all the time. I was kind of debating myself whether to mention the fact that I started using Striker just a few days ago because that's kind of so new to me. I'm like, well, do I say that or not? But I think it's always best to just kind of say, yeah, that's where I'm heading now. But just experiment and see what works for you, and feel free, if you want to clone those skills that I've got or modify them yourself, feel free to play with them. And if you find ways to improve it, you can reach out to me, find me on LinkedIn and stuff, and yeah, I'm always happy, if you can improve things, just feed it back, and that's it's all good. Cool.
Cool.
I think that's everything.
Yeah, just to wrap it up, well, thank you everyone for attending this talk. And thank you, Paul, for all of your guidance and answers. It answered a lot of questions for me. And yeah, I would highly recommend following Paul's articles and also following Paul on LinkedIn. I love his comments on different posts. It always makes my day.
Yeah, I can't help myself.
As for I'm going to drop a couple of links. So if you did not get a chance to attend this talk or you want to come back and see this talk or a section of this talk from this talk, I'm going to drop a link to our YouTube channel and all our different. We also do have a WhatsApp group. We have a meetup group, so all of you can come in and join us. And I've also again added Paul's Claude framework down there. So yep, thank you again to everyone and have a nice day.
Thank you. Thanks, everybody.